high-side and low-side switches. Here we will explore the definitions, operations, and applications of these essential components in electronic circuits. Let's begin by understanding the fundamental differences between high-side and low-side switches. A high-side switch is defined as a switch where a BJT or MOSFET is placed between the power supply, denoted as plus VCC, and the load. This configuration is crucial for controlling the power flow in various electronic applications. Here, we see a high-side switch circuit. The BJT or MOSFET is positioned between the power supply and the load, allowing for effective control of the current flow. This setup is commonly used in many electronic devices. In the OFF condition, applying 0V or ground to the base keeps the transistor turned off. This prevents current from flowing through the load, ensuring the load remains off. This is a critical aspect of high-side switch operation. For the on condition, a negative voltage below the threshold is applied to the base. This causes the transistor to conduct, allowing current to flow from VCC through the switch to the load and then to ground, activating the load. High-side switches can be implemented using PNP transistors or P-channel MOSFETs. Each type has its own characteristics and is chosen based on the specific requirements of the application, such as current capacity and switching speed. High-side switches offer advantages like keeping the load at ground potential, which enhances safety and isolation. They also reduce the risk of floating voltages. Common applications include motor control, LED driving, and power supplies. PNP transistors are preferred for high-side switching due to simpler control requirements. The base voltage needs to be lower than the emitter, allowing for easy control with ground-level signals. This makes PNP transistors more practical than NPN for high-side applications. A low-side switch is defined as a switch where a BJT or MOSFET is placed between the load and ground. This configuration is widely used for its simplicity and effectiveness in controlling electronic circuits. This diagram illustrates a low-side switch circuit. The BJT or MOSFET is positioned between the load and ground, allowing for straightforward control of the current flow, making it ideal for many applications. In the OFF condition, applying 0V or ground to the base keeps the transistor turned off, preventing current from flowing through the load. This ensures the load remains off, a key feature of low-side switch operation. For the on condition, a positive voltage above the threshold is applied to the base, causing the transistor to conduct. This allows current to flow from VCC through the load, switch, and then to ground, activating the load. Low-side switches can be implemented using NPN transistors or N-channel MOSFETs. These components are chosen based on the application's specific needs, such as voltage levels and current handling capabilities. Low-side switches offer advantages like simpler control logic, as no complex level shifting is needed. This makes them ideal for use with microcontrollers and logic-level signals. Applications include power converters, power supplies, and battery management systems. NPN transistors are preferred for low-side switching due to their ease of control. The emitter is tied to ground, and the base requires only a positive voltage to turn on. This compatibility with standard logic-level signals makes NPN transistors ideal for low-side applications. Thank you.